All right, folks. Tonight we're going to talk about slope and rate of change. Slope and rate of change. Um, Different things we're going to talk about. Slope, classifying slope as far as negative, positive, what those mean. Parallel and perpendicular slopes, some interesting things going on there. And then the rate of change. Okay? Rate of change. So, Um, those are the things we will be talking about here now, and the reason I have put this picture together is so that it would illustrate the slope these folks have towards the penguin as we have the levels going down. Just kind of a little fun thing I like to do here, just kind of put pictures together for you folks. Okay, here we go. Slope, rise over run. Rise over run. Now let's do this. Sorry, I forgot to get this up. Okay, rise over run. Oops. Rise over run. We don't need you. Okay? Rise over run. If I'm looking at a line, and let's say this line goes from here to here, the slope of this line is however far I went up to however far I went over. So I went up 1, 2, 3, 4 over 2. So the rise is 4 over the run, which is 2. So that means my slope reduces to 2. Okay? So how do we write this as a general equation? Well, let's put a couple more points on here. Let's go the slope of these two. Well, what's the rise? Well, this one's a little, dang it. I don't want to go there because it's going to reduce again too easy. Let's go right here. Okay? The rise is interesting because it goes down, so we're just going to have to make it negative. So I go down 1, 2. So the rise is negative 2. And the run is 1, 2, 3, 4, 5. Run is 5. So how do we do this and do this without graphing it, just looking at the numbers? Well, if I use the coordinates of this point, this is 3, 1. And the coordinates of this point over here are 8, negative 1. Now, rise over run. Rise is obviously dealing with up and down, correct? Which means we're dealing with the y-axis. So, if I subtract my y's, if I go 1 minus negative 2, am I going to get the negative 2 that I want? Well, we'll see. And if I subtract my x's, because my x's is obviously the run part, because that's the x-axis, it's right here, it's going horizontally. If I subtract my x's, will I get what I want? Okay? So let's do this. We're going to take and subtract my y's. So 1 minus negative 1, and put that over subtracting my x's. 3 minus 8. And what do I get? I get positive 2 over negative 5. Well, the question is this the same slope as this? The question is, that's the same slope as that? Yes, it is, because let's say I start here, okay? Rise is 2, so we're going up 2. Let me use red so you can see a little better. Rise is 2, correct? Run is negative 5. That means I'm going backwards 5. Hey, I end up exactly where I started. So yes, those slopes are exactly the same. Doesn't matter which one's positive, which one's negative. As long as one of them is negative, I have a negative slope of negative 2/5. So how do we write this in general? Well, everyone hopefully sees that when I got away from me there. Rise over run. Okay? The rise are the y's because the y-axis goes up and down. Rise, y's. So here's what we do. We subtract the y's. y1 minus y2. And where does the y1 and y2 come from? Same thing with distance and midpoint formula. If I have 2 points, this is x1, y1, this is x2, y2. So we subtract our y's for the rise, and then the run, obviously we're going to subtract our x's. Now here's where folks get in trouble. Here's where you have to be careful. It is y's over x's. Don't subtract the x's on top because they come first. It's rise over run. Y's over x's. Rise are the y's. Okay? Rise over run. Let's check my time. Doing okay. Classify a slope. In your book on page 83, there's a nice little key concept, blue box, for you to classify slope. And here we go in general. Okay? If a slope in general goes up and to the right, it is positive. Because, real simple, the rise is positive and the run is positive. Okay? If, in general, the slope is down and to the right, it is negative. Because the rise is negative, the run is positive. Okay? So negative and a positive make a negative. All right? If the slope is horizontal, okay, if the line is horizontal, that means the slope is 0. And why is this? Well, what's the rise? How far is this thing going up? It's not going up any. What's the run? Whatever I want it to be. Correct? It could be running 7. It could be running 8. Whatever value I want to put in there. I decided to put in 9. What's 0 divided by 9? 0. The slope of a horizontal line is 0. What about the slope of a vertical line? Well, let's take a look at this. This one's interesting. What's the rise? It's whatever I want it to be. It could be 7, it could be 8, it could be 100. Let's say I pick 11. It went up 11. How far did it go? What was its run? 0. Can I divide by 0? No. Nobody can divide by 0. It's very, very bad. Gets you in trouble. So therefore, the slope is undefined. Because vertical lines, the slope would be divided by 0, which is undefined. So we have positive slopes, negative slopes, horizontal lines, the slope is 0. Vertical lines, the slope is undefined. Okay? And that is all explained there in your book on page 83. Okay? Parallel and perpendicular slopes. Very interesting. Very interesting stuff here. Okay? Let's say I have a line here with a slope of 1. So that would look something like this, right? Up 1 over 1, up 1 over 1. Okay? So I have a slope of 1. So this is 1 over 1. What is a slope that is perpendicular to this? Actually, let's go easy. Let's go parallel. Let's go parallel. Well, isn't it just going to be if I start here up 1 over 1? Because parallel means they'll never intersect. So parallel slopes are equal. If the slopes are parallel, they're equal to each other because they're never going to intersect. So they have to be going up at the exact same rate or down at the exact same rate. But what about perpendicular? This is where it gets interesting. If I'm just looking at this slope that is 1 over 1, and I want to go perpendicular, won't it look something like this? Perpendicular, again, meaning 90 degrees. That's a 90-degree angle right there. What's the slope of that line? Well, it's down 1 over 1, down 1 over 1. So that's negative 1, down 1 over 1. So the slope of the red line is 1. Slope of the black line is negative 1. Now, what if it's not that easy? What if the slope is something like, is that 1, 2, 3, 4, 5, 6? We'll go right there. What if the slope is something like this? Where the rise is 1, 2, and the run is 1, 2, 3, 4, 5, 6, 7. 2 over 7. What slope is perpendicular to this? Well, it kind of comes from this. But if we look at what happens here, if I'm going to go 90 degrees to this, what happens is the perpendicular slope, and that's, remember, that's the sign for perpendicular. The perpendicular slope is -7/2, and watch. If I start at this point and I go down 7, because my rise is -7, 1, 2, 3, 4, 5, 6, 7, and over 2, because the run is 2, that puts me right there. And if I look at those lines, that is going to give me a right angle. Let's check my time. Okay, I'm doing okay. So if I had a slope of, we won't use 7 this time. If I had a slope of -13/5, what slope is perpendicular to that? Well, you do the opposite reciprocal. 5/13 would be the perpendicular slope to -13/5. Okay, we'll review this again in class, but hopefully this makes some sense, and hopefully you can see the picture so it makes sense that yes, that is going to be 90 degrees. Okay, all right, good enough. Rate of change. Rate of change. In your book, they talk about rate of change on page 85. And I'll read it to you. It's right there at the top portion of the page. Slope can be used to represent an average rate of change, or how much one quantity changes on average relative to the change in another quantity. A slope is a real live rate of change, involves units of measure such as miles per hour or degrees per day. Let's talk miles per hour because I think that's an easy rate of change. Miles per hour. Is this not a slope? If I were to graph this, wouldn't miles be the y-axis and hours be the x-axis? And if I traveled for 1, 2, 3 hours at 60 miles per hour, okay, well, wouldn't I be going 60 and then 120 miles and then we'll go out here 180 miles? And if I graph this, it would look like this. Slope, rate of change, rise over run. Hey, look, miles is the rise, hours is the run. So rate of change is one way that we can start using slope in word problems. Okay? It's not that big a deal. It's a pretty easy concept. It's slope, rise over run. But we're just going to apply it to something simple that you've all used for a very long time, like miles per hour. Concept everybody understands. Okay? There's several word problems I want to go through dealing with rate of change, but I want to do them together. So we will do those together tomorrow in class. Okay? All right. Let's wrap it up here. Slope. Oh, and I forgot to mention. Slope, the letter we use for slope is m. If I have the equation y equals mx plus b, this is slope-intercept form, correct? Slope being the m. Slope being the m. For some reason they picked m, I'm not sure why, but m always represents slope. Classifying slope, either positive, negative, 0, undefined. Parallel and perpendicular slopes, if they're parallel, they're equal to each other. If they're perpendicular, they're opposite reciprocals of each other. And then rate of change are just real-life examples of slope, such as miles per hour, okay, degrees per day, things like that. Okay? If you have any questions, bring them to class. We'll be working several examples in class to try and help you understand this stuff. Hopefully most of this is a review. This is obviously a concept you've had before with maybe a few new twists to it. But we'll definitely visit about this in class and work some more problems.